This tutorial is about how to plot the Johnson Neyman in R. I have another video about Johnson Neyman in SPSS, where I also explain what Johnson Neyman is and when you can use Johnson Neyman. If you have question about what Johnson Neyman is and when you should use that, you can go to visit that video. I will put the link down below in this video. Just to be brief, suppose that you have a y dependent variable and an x predictor and n as moderator and an interaction. You can calculate the partial derivative of y respect to the x, and that's what you got. Yes. So Johnson Neyman will tell you at which point of m x can significantly predict y. That's the basic function of Johnson Neyman. And now I'm going to shift to RStudio to show you how we can do that. Now we come to the RStudio. As you can see that I write this in the R Markdown. That's why you just earlier saw the PDF that was generated from this R Markdown. Okay, that's not the key point. Let's see how we can do that in R. So we're going to be using the empty cars, this built-in data set. The dependent variable will be mpg. That means that is the mileage per gallon. And the x, we're going to use the horsepower. Moderator will be weight. And the interaction is the horsepower times weight. So that's the model, the example we're going to use. So let's just briefly see the relationship between the mpg and the horsepower, mainly the x and y. We can run that, we can see the plot. So that's the plot. As you can see that there's a negative relationship between the horsepower and the mpg. We can also explore the relationship between the y and the moderator. So we can run that. We can see that again the car weight and the mileage per gallon is a negative relationship. So the moderator and the y also negative relationship. And as you can see that all the x, m, and y, all they are continuous variable. So these two plots help us to have a basic idea about all these three variables. Now we're going to do the Johnson Neyman plot. I'm going to use the interaction package to do the Johnson Neyman plot. If you do not have this package, you run this install package. I'm going to put all this R code in as a link down below, so you can click that to copy paste this R code to run that. So this is we import a package and then we write a linear regression model. You are familiar with the R, you kind of have some idea how to write this. So basically the idea is that we write the interaction model into this as this statement. So and then now this is the key function of plot the Johnson Neyman. It uses the model, so which is this one, and if the predictor is our x is the horsepower, the moderator is weight. So we can run that. As you can see that the Johnson Neyman function has two outputs. One is that it's telling us, the statement is that when the weight is outside the interval of 3.69 and 5.90, the slope of horsepower is significant. What it means is that this is 3.69, this line, and this line is 5.90. So that means that these two blue areas, the slope of horsepower is significant. As you can notice that the y-x-axis in this plot is the slope of horsepower, is not the mpg. Remember earlier I was talking about the partial derivative part. This is the model we're testing. This is the y, this is the x, this is the moderator, this is x times moderator. And you calculate the y with respect to the x, namely here is the mpg with respect to horsepower, the partial derivative. You will got the b1 plus the b3 and weight. So as you can see that Johnson Neyman plot is plotting this function. This is the y, this is the x. So you can see that this line actually is the slope of the b3, yes. There's another piece of information I also would like to mention, is that the range of observed value of weight is 1.51 to 5.42. this statement is telling us that in the data set, the minimum weight is 1.51. The maximum weight is 5.20. And we can actually, in R, we can do the, calculate the summary of the data set. Summarize the empty cars. And we can run it to see what the data set tells us. Empty cars. Okay, that's typo. Okay, now we see that for the weight, the minimum number is 1.51 and the maximum is 5.42. That's what this is telling us. The Johnson Neyman output is telling us. So I think that's it. I just show you how you can plot the Johnson Neyman and what the Johnson Neyman plot is telling us. Thank you for watching. If you find this tutorial useful, please like and also consider subscribe to my channel. See you in the next tutorial.